and today's date and the symbol, go ahead and write that down. And write down inverse operations undo each other. And when I say they undo each other, think about like if I gave you $5, I'm adding $5 to whatever you have. How would I get it back to the original amount that you had? It doesn't matter what you had before, but if I added $5 to your amount, how would I get you back to where you started? Dylan? Yeah, you would take away the $5. Okay, so inverse operations are things that undo each other. So you just told me that if I add something, how do I undo it? I take it away. So inverse operations would be adding and, that's an and sign, subtracting are inverse operations. So if someone is subtracting something, how do you get it back to what it was? You add it. Okay, and then the same thing, multiplying, what's the opposite, the undo of multiplying? Dividing. So if you understand these inverse operations, multiplying, this is an and sign. You can just write the word and. Dividing would be undoing the multiplication. Or if you're dividing something, to undo that, you would multiply. So these work in a pair. If I'm dividing something, I'm not going to be able to undo it by adding. And if you understand that these two are pairs and these two are pairs, then you're able to solve any equations. So getting into the solving equations part, if you have an amount that you don't know, we'll use the letter x, and you add 5 to it, and when you add 5 to it, it equals 30. So this is something that you're going to see, and they're going to say solve for x, or they're going to say solve this equation, or evaluate this equation. And remember, it's an equation because it has an equal sign. So how would I figure out, when they want you to solve for it, they want you to tell them what does the variable equal. So they're not going to be asking you to substitute. They want you to tell them for sure what does x equal or what could it equal or whatever variable that they give you. So what's happening to x right now? Is x by itself? No, it has this plus 5 attached to it. So if they added 5 to this amount, how would I undo that to get x by itself again? Think undo. If they're adding 5, I need to subtract 5. And you're always going to subtract the same amount. So all you're doing is you're saying, oh, this is adding. Let me do the opposite, the inverse operation, which is subtract 5. But if I subtract 5 from over here, I have to do it over here as well. So think of fractions, you have to do the same thing to the top and the bottom. Ratios, you have to do the same thing to the top and the bottom or to both sides. This is the exact same situation. So if you're taking 5 away, you have to take 5 away on this side as well. And if I take 5 away from 30, I get 25. And if I take 5 away, I do minus 5 to this plus 5, what does that leave me with? 0, which is nothing, right? If you get the answer 0 over here, you're good. You can get rid of it. It cancels itself out, leaving you with what?
25.
The variable. So it would now say x, bring down that equal sign, equals 25. Does anybody see a way that I could check my work? Mela?
25 plus 5.
So over here, I said that x equals 25. So now I can substitute to check my work. So write check my work. I love when we get to solving equations because before you hand in your paper to me, you already know if you're right or wrong because you can go back and check all your answers. So what I get to do is say, it told me x plus 5 equals 30. What did I say that x was?
25.
I said x was 25, so I'm going to substitute that. So I'm going to have 25 plus 5 equals, what does that equal? 25 plus 5 equals 30. So is this true?
Yes.
So if it's true, I know that my answer is correct. So you already checked your work. You already graded for yourself. Because if it works and it does equal 30, which is what it said it should have equaled, that means that you are correct. I noticed some of us were able to solve these kinds of problems on the pre-test that I gave you by just guessing and checking. That's awesome. However, you might be able to guess and check one or two things, but it's going to get harder and harder, so I really want you practicing this way. Guessing and checking will not give you full credit anymore. You have to use this method of inverse operations to solve, because that's what they expect you to understand in the 6th grade. So what is the inverse operation of addition?
Subtraction.
What's the inverse operation of division?
Multiplication.
What's the inverse operation of multiplication?
Division.
What's the inverse operation of addition?
Subtraction.
Inverse operation of subtraction. So do you see how I'm just flipping them? These match together and these match together. And if you understand that, you can solve any of these. Let's do another one. I'm going to see if you can do this one on your own. So let's do y minus 3 equals 27. You could guess and check, great, but that's not what we're doing. We need to use inverse operations, so you need to say, what is happening to my variable? And when you figure out the operation that's happening here, you need to do the opposite of that. You try it. Make sure you go back and check your work. You know how to check your work. You know if you're right or wrong before I tell you. So check your work and see if you made a mistake or if you got the right thing. All right, so let's work it through together. You should have enough time, should have had enough time to solve it. So if I see something is happening to my variable, it is not by itself right now. For me to answer the question, I need to make my variable be by itself. So right now, it's y minus 3. What is the inverse operation of subtraction? So if they're subtracting 3, what do I need to do to it, Stacy? I need to add, and I can't just add whatever I want. I have to add the same amount. So I have to add 3. So if I add 3 to both sides, remember I have to do the same thing on this side as I do on this side. 27 plus 3 is 30. And then these cancel out, leaving me with y. So I get y equals 30. So then I'm going to check my work now. And I'm going to say, okay, they told me that y minus 3 equals 27. I said that y was 30. So if I do 30 minus 3 equals 27, is this true?
Yes.
30 minus 3 equals 27. It is true, so I know that I am correct. If it was not true, then I made an error and I need to go back and check my work. I probably forgot to add 3 on this side, or maybe I wrote the wrong number down, or I did the wrong inverse operation. So let's do a harder one. We did adding and subtracting. What operation is this showing? When I see a fraction bar, what operation does that mean? Adon?
Division.
This does mean division, and it's really important that you remember that that means division. So what this is saying, and if you're uncomfortable with that, you can always rewrite it. It's saying m divided by 4 equals 4. This is the same thing, just written in two different ways. You can pick whichever one you like. What is the opposite, the inverse operation of division? Mustafa? It is multiplication. So if they divided 4, I need to undo it by multiplying 4. And I have to do it on both sides. So if I do 4 times 4, what does that give me? 16 equals, and if I divided 4 and I multiplied 4, it cancels itself out because they're inverse operations. So this goes away completely, and I'm left with m. So m equals 16. Now I can check my work. They said 16 over 4 equals 4. So that's also saying 16 divided by 4 equals 4. Is this true?
True.
It is true, so I know that my answer is correct. It's really important that you circle m equals 16, and I did not do that the last couple times. Your answer is m equals 16 for these. The true is not your answer, you're checking your work there. You're checking to make sure that m equals 16. So in fact, I'm going to go back, and I'm going to circle these answers too. I said x equals 25, and I said y equals 30. So whatever you say the variable equals, that's your answer. The whole thing. Don't just circle the 16. Don't just circle the 30. You need to circle m equals 16, or whatever variable equals that number. Any questions about that? All right, let's do one more, and then I actually have a practice sheet where you are... We used this last year for Pi Day because we were a couple weeks ahead because we did a different order of units. So you have a page that looks like this with the alphabet, and you're just solving for, it looks like x every single time, so the variable stays x. And then over here you have different messages that have to do with Pi Day, and it's like you're sending me a letter, and you put your name on the backside as from. Okay, so it's kind of like, think Valentine's Day-ish, you're giving me like a Valentine, but it's for Pi Day, even though Pi Day is over. So this is a good practice because it gives you the same thing over and over and over again. You get to practice solving. Let's do one more, and then we will work on that. So if I have... P equals 100. Is P by itself right now?
No.
It has a 5 attached to it. What operation is this? When there's a number, cough, cough, a coefficient, right next to a variable. What operation is that when there's a coefficient right next to a variable? Nancy?
Multiplication.
It is multiplication. So this is showing me multiplication. It's showing me 5 times P. How do I undo that? Right now, 5 is being multiplied. How would I undo that? Think inverse operations. Nathaniel?
Division.
Yeah, so what is happening to P? 5 is being multiplied to it, right? So I need to divide what?
5.
Divide 5. My goal is to get this variable by itself. If I divide 5 over here, I have to do it over here. When I divide 5 and it's being multiplied, it cancels it out, leaving P. And what is 100 divided by 5? 20. So P equals 20. And then I can check my work because I can say 5 times 20 equals 100. Is that true?
Yes.
5 times 20 is 100. That is true. So I know that P for sure equals 20 in this case. Okay, so I gave you an example of a division problem. I gave you an example of a multiplication problem. I gave you an example of a subtraction problem and an addition problem. So you have examples of all 4 types of solving equation problems that you're going to see today. And if you need help on your Pi Day worksheet, you need to go back and look at these notes and see what I did. Okay? I want to do, sorry, I'm looking at the sheet and I want to do one more example because it looks a little bit different. So really fast, I see something that looks like, it's not exactly, but it looks like 10 plus x, because they used x, equals, let's say 25. I changed it a little bit, but notice how the x does not come first here. What operation is happening to the 10 is what I want you to see. Because usually that sign is in front of it, but it's not. There's nothing in front of this. What operation is happening here? Jose, what operation do you see happening between the x and the 10? Is it adding, subtracting, multiplying, or dividing? Right here. It's adding. So even though that addition sign comes after, that's okay. I want you to subtract 10. Okay? Subtract 10. And then over here, subtract 10. And the reason that works is because this is a positive 10. We know that because it does not have a negative sign. So if it's a positive 10, they're adding 10. If I take away 10, I'm left with 15. X equals 15, and I could then check my work and say, does x plus 15 equal 25? Yes. Sorry, thank you. 10 plus, what is x? 15. 10 plus 15 equals 25. Dylan, why did I not do x minus 10? Because this is a positive 10, not a negative 10. And I want x to be by itself. I don't want to take the x away. I want to make it alone. So the way that I would make that alone is saying, okay, this is adding 10. It's a positive 10. So I need to get it to go away, and I need to do that by taking it away. So think about how we have the commutative property, and these can be flipped. I'm doing that in my head, and I'm saying this is the same as x plus 10. If it was subtraction, I couldn't do that. If it was negative 10 plus x, I would have to add 10 to get that back to 0. So, but we're not doing that today. That's a little bit more advanced. But that's the reason I'm subtracting 10 is because it's on the positive side, and I need to get it back to 0 by taking it away. Mustafa? Yeah. Yes, Nathaniel. All right, so go ahead and start the Pi Day sheet. It is, for you guys, I'm going to pass it out. For you watching the video, it is at the circle table. Please grab it. Or I might have it in your baskets. You need one of each of these pages. You need one of these to answer at the very end, and you need this to do your work and show your work. I want you showing your work. So if this is not enough space for you, you need to grab a piece of lined paper.